I'm Anagara, a product manager at Kestra. Today, we'll enter the labyrinth of orchestration silos, and then I'm going to show you a way out. Let's start by defining what do we mean by orchestration. Orchestration is about automated coordination, whether for deploying infrastructure, executing data workflows, or streamlining business processes. The goal is to guarantee a reliable sequence of steps while maintaining visibility into the who, what, when, and why of each operation. To understand why orchestration is needed, imagine the following scenario. A request lands on your desk to continuously move data from system A to system B. To accomplish that, first you write a script. Then you need to schedule and deploy that script. Because serverless functions is the go-to solution for simple script deployments, you decide to use AWS Lambda. You set up a Lambda function on AWS, you add a schedule trigger, and you call it a day. Over time, you get requests to integrate data from more and more systems. With each new system, you need to write more scripts. And those scripts become increasingly interdependent. Now you also need to guarantee the correct sequence of steps, even if some of those scripts fail. Scheduled Lambda functions alone cannot handle this increasing complexity. To tackle this, you opt for AWS step functions, because that's the default service to orchestrate Lambda scripts. You go to the AWS console and you configure the service to ensure that your Lambda scripts execute in the right order. With more and more requests, you realize that custom scripts to move data don't scale. You adopt Airbyte and dbt for more scalable data pipelines, only to find that step functions, your orchestrator, falls short in supporting them. Fortunately, there are many open source tools that can orchestrate Airbyte and dbt seamlessly. So you decide to use a default data pipeline orchestrator for Airbyte and dbt while sticking with step functions to orchestrate Lambda scripts to avoid migration headaches. Over time, the same pattern keeps repeating. The stakeholder comes in and asks, could you just update that one table? Could you just build that new Docker image for me? And the list goes on and on and on. The phrase, could you just, becomes your recurring nightmare. Each new request leads to yet another default tool that works well until it doesn't. Before you know it, you're juggling all kinds of orchestrators. One for microservices, another one for data ingestion, data transformation, ML, LLM, build pipelines, business processes, reverse ETL, automation workflows. And this is what we mean by orchestration silos. When each use case requires a dedicated orchestrator, the complexity keeps growing until your platform becomes nearly impossible to maintain and understand. And the problem is not just about tools. It's about tooling decisions being misaligned with operational reality. Users have their own diverse needs, and if the tooling doesn't support them or is too complex, end users will find shortcuts and workarounds to find a solution that is aligned with how they work. They will build hidden spreadsheets, cron jobs, Zapier automations, or GitHub actions scattered across repositories. We end up with orchestration silos without even knowing that they exist. The example with growing complexity over time shows that we can solve silos by adding more silos. In the same way, we can solve complexity by adding more complexity. Hyper-specialized tools work great initially, but they fall short the moment you apply them to new, more advanced use cases. So how can we break this cycle? How can we escape this labyrinth of orchestration silos and solve that problem? To solve silos without creating new ones, we meet users where they are. We ask them how they want to work. If they want to write code from a local IDE, the orchestrator should support it. If they prefer to avoid the pain of packaging and deploying code, we should also support it. Then we can simplify the solution by aligning the tooling with how end users actually work. And that's the problem we're aiming to solve at Kestra. We believe that you should be able to create your data pipelines via user-friendly UI while keeping the advantages of workflows as code. We enable users to create data pipelines from wherever they feel most comfortable. It's up to you to decide whether you want to build everything as code, everything from the UI, or a combination of both. This includes local IDEs, embedded Visual Studio Code Editor, or simple UI forms. Many of our users create workflows from a local IDE by leveraging Kestra VS Code extension that provides auto-completion and syntax validation without having to touch the front end. If that's your preference, you could disable the built-in code editor in a production environment to ensure that your pipelines are only edited using CI/CD. However, CI/CD is not the only way you can interact with the platform. You could configure everything from the UI. Our front-end application is not an afterthought. It's a first-class citizen. All data pipelines created via UI generate human-readable YAML configuration that is organized into namespaces and automatically versioned, just as you would with Git. You keep the advantages of workflows as code without the pain of dependency management and packaging code. And since both engineers and the end users they support can work from the same platform as equals, you can prevent new silos and enable everything as code and from the UI. To meet users where they are and remove the need for new silos, Kestra easily integrates with tools you already know and love, like Airbyte. Because each plugin is a single binary file, there's no package dependency hell, even without using Docker. These integrations reduce the complexity of orchestration, and in combination with blueprints, they enable hundreds of use cases out of the box. And thanks to open source contributions, the list of supported plugins keeps growing with every new release. Here is a quick demo showing side-by-side how you can interact with Kestra from the UI and from the code IDE. Everything shown here is fully open source. On the left, you see UI forms that generate YAML files that are automatically versioned and maintained as code. And on the right, we use the embedded Visual Studio Code Editor to add custom Python scripts, SQL queries, or dbt projects. Then we can schedule and orchestrate them without having to worry about deployments and infrastructure. And this is how we combine everything as code and from the UI. And with that, let's summarize the key takeaways. We can solve complexity by adding more complexity. Instead, we should meet users where they are and adapt to your evolving needs. And lastly, try Kestra. If you want to stay in touch, you can find us on GitHub, X, LinkedIn, Slack, and on our website. Thank you for listening, and see you next time.